Assalamu alaikum students. In this video, we will discuss that what is evaporation, vapor pressure and boiling point. Page number 104. Now, evaporation. Properties of liquid. First of all, evaporation. Now students, you know what is evaporation? Evaporation is that spontaneous escape of high energy molecules from liquid surface into vapor state is called evaporation. Now liquid state change into vapor state. This is called evaporation. Now student, is that clear? What is the evaporation? Spontaneous escape of high energy molecule from liquid surface into vapor state is called evaporation. Students, and simply we can say that हम यूँ कह सकते हैं कि evaporation is the process of the change of the liquid to gaseous. Now students, evaporation is the process of the change of liquid to a gaseous state below its boiling point. Now remember student, remember that evaporation is the self phenomena and takes place at all temperature below the boiling point. Now evaporation is that gas molecule high energy molecules. Now say that high energy molecules. Student, is that clear? The process by which a liquid changes to a gas phase. Evaporation. The process by which a liquid changes to a gas phase is called evaporation. Now student, is that clear? Evaporation? Evaporation is endothermic reaction. Now endothermic reaction. What is the meaning of endothermic reaction? Endothermic reaction is that reaction in which heat is absorbed. Heat absorbed in this reaction. This is called endothermic reaction. For example, clothes dry under the sun due to evaporation. Now student, clothes dry under the sun due to evaporation. In this process, water is converted from liquid state into vapor. Now we can say that water in a liquid form, vapor now in a gas form. Student, is that clear? The molecule of liquids are in continuous motion. Molecule of liquid are in continuous motion. Molecule of liquid. They collide with each other, but all the molecules do not have same kinetic energy. All the molecules do not have same kinetic energy. Majority molecules have average kinetic energy and few have more than average kinetic energy. The molecules having more than average kinetic energy overcome the attractive forces among the molecules and escape from the surface evaporation. We can see that it is directly proportional to temperature. It is directly proportional to temperature and increase in temperature and also increase in temperature. Now student, is that clear? Evaporation. Now एक बार फिर से बता देती हूँ. The process by which a liquid changes to a gas phase is called evaporation. Evaporation is endothermic reaction in which heat is absorbed. And simply we can say that evaporation is the process of the change of the liquid to a gaseous state below its boiling point. Is that clear? Now student, page number 105. Page number 105, factors affecting evaporation. Factors affecting evaporation. Now, first of all, surface area. Now, second, temperature, factor affecting evaporation. Now, third is intermolecular forces. Now, the first one is surface area. Students, factors affecting evaporation. Now, factors affecting evaporation. First of all, surface area. Surface area. Now, the evaporation is a surface-based process. Greater the surface area, greater is evaporation. Student, this point is clear. Greater the surface area, greater is evaporation. For example, water left in bowl evaporates slowly. Then water left in a large tub, a saucer is used to cool the tea quickly. Then teacup. Student, water in a glass. Student, water in a glass. Water in a glass. Now, water is sprinkled on floor. Water is sprinkled on floor or roof. Now, less surface area. First point is less surface area. Water in a glass, less surface area, less molecule escape as gas. Second point, less molecule escape as gas. Now, more surface area, we can see that more surface area, water sprinkled on roof. Our second point is more molecule space is gas. More molecule escape as gas. Student, is that clear? Factor affecting evaporation is surface area. Now, the second part is temperature. Temperature, factor affecting evaporation, its second point is temperature. Student, the rate of evaporation increase with the increase in temperature. The rate of evaporation increase with the increase in temperature, because temperature increase the kinetic molecular energy which overcome the intermolecular forces and makes evaporation rapidly. For example, clothes dry quickly in a sunny day than a cloudy day. Student, for example, clothes dry quickly in a sunny day than a cloudy day. Now, temperature. First point is increased kinetic energy of molecules. Temperature. Factor affecting evaporation. Factors affecting evaporation. Second is that temperature. First point is increased temperature. First point is increase temperature. Now the second point is increase kinetic energy of molecule. Second point is increase kinetic energy of molecules. Now the third point is more surface molecule overcome more surface molecules overcome the force of attraction. The force of attraction. Students, get clear? Factor affecting evaporation. First of all, factor affecting evaporation. First point is surface area. Students, get clear? Surface area. Now this is temperature. Temperature. First point is increased. First point is increased temperature. Increased kinetic energy of molecules. More surface molecule overcome the force of attraction. Now the third factor affecting evaporation is this intermolecular forces. Now intermolecular forces, the rate of evaporation increase with less intermolecular forces. If intermolecular forces are stronger, evaporation is lesser. Students, that clear this point? If intermolecular forces are stronger, evaporation is lesser. For example, perfume have lesser intermolecular forces. Perfume has lesser intermolecular forces than water, therefore it evaporates quickly. Student, is that clear? Intermolecular forces factor affecting evaporation. The third point is intermolecular forces. Now, third point is intermolecular forces. Student, this is glass of water. Water. Non-volatile. Water. Non-volatile. Because non-volatile, glass of water non-volatile because more force of attraction. Because more force of attraction. Student, is that clear? More force of attraction. We can say that strong force of attraction. Water. Is that perfume, ether, volatile. This is bottle of perfume, volatile because weak force of attraction. Because weak force of attraction. Ether have less force of attraction. Now we can see that have less force of attraction. Student, is that clear? Intermolecular forces. Now we study factor affecting evaporation. First point we study surface area. Surface area point is less surface area. Water in a glass, less molecule escape as gas. More molecule escape as gas. More surface area. Water in sprinkler or floor or roof. Temperature increase kinetic energy of molecules. More surface molecule overcome the force of attraction. Now intermolecular forces is that. Third point is water non-volatile because more force of attraction. perfume volatile because weak force of attraction. Now we can say that a strong force of attraction, and this is ether have less force of attraction. Student, I hope you all are understand. Now the next topic is vapor pressure. Now the next topic is vapor pressure. Acha students, vapor pressure. Understanding vapor pressure. Now what is the meaning of vapor pressure? What is this vapor pressure? Acha students, vapor pressure is that exerted by vapor in equilibrium, whether it's pure liquid at a particular temperature, is called vapor pressure. The equilibrium is a state when rate of evaporation is equal to the rate of condensation but in opposite direction. Student, is that clear? Now consider a liquid in a closed container. Student, consider a liquid in a closed container. Initially the liquid is changed into the gaseous state. Student, is that clear? Liquid is changed into a gaseous state, and we know that at the beginning the rate of the evaporation will be fast, where is no condensation, as you can see that this diagram. Now the diagram is A. Evaporation, now rate of evaporation. Second diagram is rate of evaporation. Now the third diagram is evaporation equal to condensation. Student, the rate of evaporation is greater as compared to the rate of condensation. Student, the rate of evaporation is greater as compared to the rate of condensation, and we know that the evaporation is change of the liquid. Evaporation is change of the liquid into the gaseous state. This diagram is that. Now the rate of evaporation is slow and slow. Rate of evaporation is slow and condensation is fast. So ultimately the two rates become equal. Now the two rates is evaporation equal to the condensation, as shown in the figure C. Evaporation equal to the condensation. Now student, is that clear? That's it.